Is there anybody out there? Electromagnetic waves. So our learning intention is we're going to understand how we use electromagnetic waves to communicate. So we're looking at the use of them for communication. So we're going to end up being able to give examples of how we use light, radio waves and microwaves in communication. And we need to also think about the benefits and the problems of using these different types of waves to communicate. So an electromagnetic wave can actually be used for communication using wires, so wired communication, or wireless communication. And the three types of wave that we're going to explore are radio waves, microwaves, and visible light. So radio waves, you'll be familiar with the radio, so radio waves are used for radio, but also television signals are sent by radio wave, and Bluetooth works by radio waves. It is wireless, and here is a picture of a radio antenna. So you might see those in the landscape. We have different frequencies that we use for radio waves, and you can actually tune in your radio. So you might have seen this in the car when you pick a different frequency for different radio stations. So you tune in your receiver to pick up a different frequency and hear different communications. Microwaves. Microwaves are also important for wireless communication, and microwaves are the ones we use for our mobile phone, for Wi-Fi, and also for radar. They can travel through the atmosphere and actually leave the atmosphere, so it allows us to communicate around the globe using satellites to send the signal. And the third type of electromagnetic wave we use for communication is light. And it's really fairly obvious that we use light to see things, and we can communicate just by looking at somebody or reading information in daylight. But we can also send light signals along optical fibers, which are actually glass tubes, and they can be used for very high-speed wired communication. So when we think about electromagnetic waves and communication, we can pick a different type of wave depending on what we want to communicate. And we need to think about the different situations we're in because, for example, you don't want to use light waves to communicate if there's a wall in the way, because light doesn't travel through walls. But you might use it use communication of microwaves or radio waves if you're inside your house, because they do travel through the walls. So you need to have a think about what you want to do, what situation you're in, and which electromagnetic wave you might choose to communicate with. We also have to think about reflection. So when you think about radio waves and microwaves, they can actually bounce off substances like light does. And that's really important because you might think about where you position yourself. For example, with your Wi-Fi box, the router, you might want to think about what materials it's got to pass through, but also what materials it might bounce off. And the signal also gets weaker the further it has to travel. So the further away you are from your Wi-Fi router, then the less likely you are to get a strong signal. So what is it that determines whether a wave can travel through a material or not? Well, that is the frequency. And this is linked to the wavelength as well. And for example, you can use AM radio waves, which are low frequency. We know that they bounce off the atmosphere, so we can actually use them to send some signals around the globe, bouncing them off the top of the atmosphere, and that'll take them around a hill or over buildings or past mountains, which might have blocked the signal. If we use low frequency radio waves, we can get them round the globe. And we can also choose to use high frequency radio waves as well as microwaves if we know that we want to use satellite communication or to speak to space stations. So you can have an uplink, so we can send the signal from one dish on the ground, from the ground station, up to a satellite, and then that's gone through the atmosphere and into space, and then we can receive the signal at a second ground station, which might be a long way away. So this is fast and efficient. So when we look at the whole spectrum, and remember electromagnetic waves can range all the way from one end of the spectrum where it's really high frequency, so gamma rays, all the way down to the other end of the spectrum with low frequency and low energy radio waves. Let's have a look at whereabouts our communication waves are. Well, we've got radio here, microwaves, and visible light. Now you'll notice that they all appear down this end of the spectrum. So low energy, low frequency, long wavelengths, and also, most importantly, not very damaging. In fact, not damaging at all. So these communication waves are safe to use. We would not want to use gamma rays or X-rays because they can actually damage DNA. So you don't want to be using those for communication.